All right, so in this lecture I would like to talk about something that we often neglect in writing software, namely the role of documentation. So most of us, of course, start a project on a, let's say, fairly small level. We write a few lines of code for ourselves and we think, well, I know what it does. I don't need to document it on various different levels. But then there comes a point where, of course, the software outgrows the expectations that we had for it. Maybe somebody else is going to start using it. Maybe it becomes something that we build further work on and that we want to use for a few years. And so one of the things that I would like to talk about is a little bit, let's say, how do you document codes? What is the sort of process that's behind it? And one of the other important parts is, what are the tools that can help us with this? So this is lecture number 23. And in particular, one of the things that I would like to talk about is a tool that is called Doxygen. Doxygen is a documentation tool that we use all through deal.II. As a matter of fact, that is widely used in industry and in open source projects. There are very, very large documentation projects that use Doxygen. So this is today the tool to use for this. This is, of course, part 3 of my mini-series on learning how to use modern tools. Part 1 was Eclipse, Part 2 was using Visit as a visualization tool. So let me start by defining what documentation actually is. So documentation, I would say, is the collection of additional information that is not just, let's say, the actual source code. And it comes in many different possible ways. So for example, it could be implicit in the code. For example, in deal.II, when we have functions that return the number of something, we often call them n underscore something, so n cells, n active cells, and so on and so forth. So in a sense, this is documentation as well, right? It is something that explains to the reader, without actually saying very much, what this function does, namely it returns a number. This is implicit documentation, if you want. Then it could be part of the actual code. So for example, the assertions that I talked about several lectures back, where we make clear in the code that we expect a certain condition to be true, let's say at the beginning of a function or at the end of the function or somewhere in the middle. This is a sort of documentation as well, right? We document that we expect a certain condition to be true, and we instruct the compiler to actually verify that this is so. Then, of course, traditionally what we think of as documentation would be comments embedded in the code. So you have seen this many times in your own code or in other people's code, that we have comments in there that say, okay, so this variable does this and that, and it's used in the algorithm below to store whatever. This is certainly, let's say, the most obvious way of writing documentation, but it is not the most important one, I would think. And then you can have other kinds of documentation, for example, design documents that would be in entirely different, separate documents from the actual code. So with documentation defined like this, I would like to introduce you to a number of observations people have made about documentation over the last, 60 years, 65 years of computer programming now. Namely, the first one would be that documentation is not just for others. You might think that you don't need to write documentation for your own codes if you are the only one who's ever going to use it. But that's short-sighted, because typically what you will find is that if you work on the same code, let's say you write 100 lines of code a day. It's a good average, 100 lines of code a day, if this is what you do full-time. Then let's say in half a year, you write on the order of maybe 15,000 or 20,000 lines of code. You might not remember anymore what this algorithm actually does. You might not remember what this function does if you don't write it down. And you certainly might not remember how these 7 functions that somehow form a block, how they interact. So with this observation that we ourselves forget stuff, the consequence is that we have to write documentation not just for others, but that we have to write documentation for ourselves as well. So when we record these lectures here, it is January 2013. deal.II had its 15th birthday about 2.5 months ago. There is a lot of code that I know I wrote that I have no recollection what it does. Things that I just don't remember. I know this class is by me. I do not recall how this algorithm works, what this function does, and so on and so forth. The only way I can deal with this sort of code if I need to find a bug in it, or if I need to extend it, or if I need to use it somewhere, is if I have documentation that tells me what the algorithm actually does. So you will realize at one point that if you don't write documentation, you will regret not doing it in a relatively short amount of time. It doesn't have to be in 15 years. It could be just a few months from now. The second observation is that documentation is necessary on many different levels. So you think that we should just have comments in the code. That is not the only appropriate level for documentation. So in the code you would document, for example, how do the next 10 or 20 lines work? What's the idea behind this? But then you should also have documentation about, let's say, what does this function do? Let's say, independent of the actual algorithm that implements what this function does, you should just have documentation what the function does, not how it does it, but what it does. Then you would want to have documentation that describes, let's say, the interaction between different functions and classes. So in deal.II, what you often find, of course, is that the documentation in the manual is typically of the kind where we describe what a function does or what a member variable does. But then we have these additional modules that describe how classes and functions interact. Then you might have a design document, something that describes, for example, how we approach problems, how we see them. So what, let's say, for example, if you talk about the data structures used to store a triangulation, that we see a triangulation not just as a collection of cells, but in fact as a quadtree or as an octree. That would be appropriate for a design document. And then there will, of course, be something like a README file or installation instructions that explain to other users how to use this thing, or what is this switch to CMake doing? What is this switch, or what does this target when we call make doing, and so on and so forth. One of the things that I've forgot to write down here, of course, is the tutorials. So if you write as a library like deal.II, then you will want to have tutorials that illustrate how to use these different pieces. Okay, so observation number 3 is that documenting code is a process. You might think that we should just, write our code, and when it works, then we're going to write the documentation. That turns out to not work. Never. If you don't think of documenting code as part of writing software, as an integral part of programming, then you will not be able to write high-quality documentation because, for example, you will have already forgotten what the code does by the time you want to document it. And of course, one of the other things that you will find is that you don't typically have the time to document it anymore after you've already written the code. You move on to other things. So it must be an integral part of the programming process to write the documentation. There are a number of corollaries to this last observation that it must be a part of the process. Namely, documenting code can make it better. And there are 2 different approaches to this, let's say from a philosophical or from an approach level. Namely, you can ask the question, should I write the documentation first, or should I first write the code? if I take this first approach, where I write the documentation first, this is often called design by contract. So what I'm going to do, for example, is I'm going to say, okay, I need a class that does this and function that does that. So I specify up front in detail what the code is supposed to do. I'm not going to say how it's going to do it, I just say what it is going to do. And so I have a contract, essentially, that says these are the things this class promises to do, and then in the second step, I go about implementing it. One of the things that you can do with this design by contract is that you can write tests that already implement a validation or a verification of what this code is doing before the code is actually written. So for example, I have a document that says this function is going to compute that. I can write a test that calls this function with a particular input and verifies that the output is correct. And then I can go about actually implementing this function and making sure that what it returns is in fact what the test wants to see. So this is something how I typically work, that oftentimes I write down what I want this function to do, I write a test, and then I implement the function, and I'm done with this function when the test or the tests actually work. So as I say, this is called design by contract. The other option would be that I write the code first and then document it. And that too can make your code better. Because one of the things that, that you have to do is when you first write the code, then later on you will have to document it. And what you often do in order to document it is that you review your code again. You ask, well, okay, so in this corner case, what was it again that the function computed? And then in order to write it down, you have to look into the code. When you review code, you will always find places that you can do better. Reviewing code is an unimaginably important part of making code better. If you have multiple people who look at the same code, or if even you look at the same code again, you will always find places that are unclear, where corner cases are not appropriately handled, and so on and so forth. So for example, you might have forgotten to write assertions. And you might ask, well, so what does this function actually do if I try to access an element of a vector that doesn't exist? These sort of things are things that you typically discover during code review. So when you write the documentation afterwards, you have to look at the code again, and you will almost certainly find places that you can improve. So even for writing code, even for writing documentation after writing the code, you will get better code. In practice, it turns out that design by contract is more successful and leads to better code. Because when you first write the code, oftentimes you're not entirely clear what it is supposed to do. This is, let's say, for example, you write a sort algorithm, and you think, well, okay, all I need to do is to sort these objects. But then you could start to ask the question, well, what if I have two objects that compare equal? So for example, let's say you might want to sort people by last name. When you sort names, then you typically do this by, for example, converting every name into uppercase and comparing the uppercases. But what do you do with names that have, let's say, a mixture between upper and lowercase? So in the sorting algorithm, one of my colleagues is called Ron DeVore. He spells his name D-E and then the capital V-O-R-E, all in one word. So if you have this sort of thing, how should you sort this spelling of DeVore compared to the spelling with, let's say, only the uppercase D and then all lowercase words? They compare the same, and these are the sort of things that you probably want to think about when you first write the design, when you first write the contract. Namely, you specify how this function works, and then it becomes quite clear how you need to handle this in your sorting algorithm, which one of these comes first. Whereas if you first start to write the code, in practice, it will be often difficult to think of these sort of things because your mind is set on writing the code and not on what the code actually is supposed to do. So in practice, design by contract often works better. You first write down what a code is supposed to do, and then you actually do it. A fourth observation would be, it is difficult to keep documentation up to date if you do it in a separate file. That if you change one file and the documentation is somewhere else, it becomes very difficult to make sure that they always stay in sync. And the appropriate response to this is that we need to find ways to extract documentation from code, that we can write, for example, the description of what a function does right where we declare the function, so that the number of arguments and the types of arguments that is in the documentation matches the actual function declaration, for example. So it's much easier to keep this in sync if the documentation of the function arguments is a few lines up from the declaration rather than in a different file. And so what we need to come up with is tools that extract documentation from code and then present them in either a printed document or on a website. And that's, of course, exactly what we do in deal.II. So if you have looked at the tutorial programs, for example, you will find that all of the text that you see on the website for step 1, step 2, step 20 is actually right in there in the code, which is sometimes a little bit annoying, and that's why we have this target where you can say make strip comments to remove the comments, because oftentimes we don't need them anymore if you keep continuing to write it. But it would be impossible for us to document these tutorial programs if it was not in the same document. And the same is true for all of the other documentation in deal.II. It is right in the header files where we declare these functions. So we need to have tools that extract documentation from code. Where I'm going with this is that these tools exist. And the tool to use is called Doxygen. Doxygen is a tool that extracts documentation that allows you to annotate code in the form of comments. I'm going to show you exactly how to do it. And also allows you to include additional documents that are cross-referenced and cross-linked. So if you want to go find this tool, it's at doxygen.org. So let me just show you a little bit how this works. So here's an example of a function, a very simple one. Let's say integer power. Okay, so what I want this function to do is that it takes a double and an integer, and that it returns a double x and an integer n, and that it returns x to the n. So what I should do is I should write right in front of this function a comment that explains exactly what it does and what the meaning of these arguments are. And it's maybe a little bit difficult to see through this here because there is so much markup. Typically there's not that much markup. But the way this works is that in Doxygen you start a comment with /**, and then you typically write a documentation where you can use HTML markup. So code in /code here, for example, would print this as in typewriter font. So it says compute and returned the nth power of x. And then there are a lot of these add commands here. So add param, for example, documents the parameter x. Actually, I think the appropriate terminology in C and C++ would be it's an argument to the function, but anyway. So it documents what this x is, namely it's the number to be raised to a certain power. Then there's an add param n for the exponent, and then an add return that documents what this function actually returns. And what you see here is that I can embed LaTeX formulas in add f for formula $, and here is the closing tag, x to the n. So that should come out as a LaTeX formula. And so if I send this sort of text snippet or code snippet through Doxygen, the way it comes out is going to look like this. Okay, so I have a screenshot of a browser here. So it's going to have the name of this function here and what data type it returns. It lists the arguments. It shows me the documentation that I have. You can't see, but it is in fact typewriter font for n and x here. And then it lists these parameters, x and n, with their own description, and it says what it returns as a formula, x to the n. So all of the documentation of deal.II, of course, is generated by Doxygen. You will immediately realize, or let's say recognize, that this is exactly the sort of format that we have. Here's a second example. So let's say I have a class Frobnix, one of the classic names of classes in giving, let's say, code snippets. So I have a class Frobnix. I'm going to document what exactly it does. I'm going to reference another class called dubstep that I'm just going to introduce here. I'm going to reference a group of classes. That's the equivalent of a module. And I'm going to say who wrote it. So in this case, I wrote it. So if I send this one through Doxygen, and if there is such a module here, and if there is such another class, then the output will look like this. So there will be a documentation for this Frobnix class. It will have a reference to the module which it is part of. There might be multiple of these. And then it has a detailed description of the class. It lists me as the author. And you will see that it already highlights here this dubstep class. So when I created this example that I sent through Doxygen, of course, there was a different class called dubstep that I had somewhere. So it automatically inserts a link because it recognizes the name of this other class. And the what comes out then is HTML, where I can actually click on this and I can automatically go to the other class that is being referenced here. It also tells me where, in which file this happened, and so on and so forth. And in which directory this happened. So Doxygen, as I say, it produces documentation that cross-references everything, and that's part of the power of it. That if you write documentation in a traditional document, in a Word document, or in a LaTeX document, it is impossible to follow these sort of links. I mean, you reference a class, but you would have to leaf through through your document to find the documentation of this other class. And I think that goes very much in the same direction as, let's say, how we used to use dictionaries or encyclopedias, and how we today use, let's say, for example, Wikipedia. That in the old days, it was difficult to look up a different term in an encyclopedia. Today in Wikipedia, we just click on it, we look at it, and we jump back. And Doxygen enables exactly this sort of exploration of code, where you see something else referenced, you don't quite understand, you just click on it, you read through it, and you go back, and now the context makes sense. Doxygen is a tool that really provides you with all of this cross-referencing. Doxygen supports documentation at all levels, so it's quite happy to extract documentation from individual function declarations and class declarations, but it also supports modules, and in deal.II we also send the tutorial programs through Doxygen, for example. It has many, dozens of these add commands that allow you to mark up text, that allow you to mark up individual function arguments, that allow you to mark up other places to reference. It allows you to insert HTTP links, so URLs, for example. There are many of these add commands that allow you to create high-quality documentation out of this. Doxygen is the tool that we use in deal.II, as I mentioned. I think, I haven't counted this recently, but a while back we had somewhere between 8,000 and 10,000 pages of documentation. It is all extracted by Doxygen. And it is all cross-referenced, and it all runs in just a few minutes. So Doxygen is certainly a tool that is not only usable for small projects, but that can be used for incredibly large projects as well, like deal.II, that have hundreds of thousands of lines of code and that need to reference all of these sort of pieces of information. So I hope what I was able to tell you is the importance of documentation. That documentation is something that you have to do as part of writing code, not just for yourself, not just for others, but also because it makes your code better. That if you do not document code, it will not be high quality code. It's just not feasible to do it. that you have to describe what it does to really understand how to implement it. And that one of the tools that you have is design by contract, where you first specify what it's supposed to do, and then you actually write the code. And when you have the specification, you write it in a format that can be extracted by a tool like Doxygen, and to create websites, for example, out of this. So I hope that you give this tool Doxygen a chance. Take a look at how we mark up things in deal.II if you want to have an example, and use it for your own programs as well.